Once again, we want to thank everybody for coming today. We have about 200 people off-site in addition to the 120 we had registered. I don't know if we had 120 here, but yeah, it's been quite a lot of interest. We're going to work with the Indiana Office of Energy to see about replicating this and helping them with some further outreach. But you also, in your packets here on campus at Purdue, had received a yellow evaluation sheet. If you could just take some time to fill that out and then put it on the back table as you exit this afternoon, that would be very helpful for us. It would be in your black folder. But certainly we appreciate your interest, and we'll be posting this session. We're video streaming the event, and it'll be available for download on the Renewable Energy website here at Purdue. So check that out afterwards. If you had some folks that couldn't make it, we should be able to help you gain access to that after the event. So I'll turn it back over to Clay to wind up today.
Uh-huh.
You know, I'm wondering, how could you maybe get it out a little bit more to the public?
Well, I do know that our good friend Chris Norman back at the Indiana Office of Energy was answering a lot of phone calls, and we had to turn some people away from this site. We would certainly be, I think the best option for folks that are interested in wind energy down the road long term in Indiana is to take a look at coming to the Wind Indiana Conference, because that'll be at the Indianapolis Convention Center. We can facilitate exceptionally large groups like we've had today, and even more. So take a look at that opportunity down the road in July 21st and 22nd. So we appreciate that, and we'll certainly continue to work on these types of programs in the future.
Yeah, and this is by far one of the nicest sites we've done it at. Really nice. Towers. So we got this machine up in the air. The fuel is up there, not down here. The biggest thing that a homeowner is going to cheap out on is a tower. And tower is going to be about 20, 25, 30% of the cost of the system. There was an installer I know of who did a lot of repair work and remanufacturing of equipment that didn't exist anymore. And he surveyed his customers. He had customers in 40 different states. And he surveyed them, and he's like, okay, if you had to do this all over again, lessons learned, what was the number one thing you would have done different? Number one reply, we wish we would have built a taller tower. Number two response, we wish we would have built a taller tower. Number three response, we wish we would have built a taller tower. That's where the fuel is. That's going to affect the performance of your machine. And it's far easier to add on a couple extra sections in a tower than it is to have a larger machine. That's where the fuel is. So we're going to deal with three different types of towers. The freestanding, guide lattice, and tilt-up tower. There is the monopole out there, which is, again, like this huge gargantuan tube or light pole that goes up. Lots of concrete in the ground, lots of steel to hold this lever upright. You won't see very many of those in residential applications because they're very expensive. Some municipalities, Mequon, Wisconsin, totally open to the idea of wind energy, but you can only have a monopole. So that kind of eliminates many of the people that could afford one or are interested and can afford it. But there are monopole applications. Here we have this is a chart off of our tower for 2002. Variations in the wind. We have tremendous amounts of energy in this winter, spring, and fall. Virtually nothing in the summertime. Power carriers, you've been through that. Doubling the wind speed, 8 miles an hour to 16. 8 times the power. Just looking at the variations in same longitude, same latitude, different heights, 46, 66, 86 feet. Difference between the top and the bottom, 11 versus 7 miles per hour. 1,000 more units of power, just 40 feet up. All right, two tower sections. Freestanding tower. Most expensive tower out there, minus the monopole. The bottom 20 feet of this tower is going to be as expensive as everything above it. Tremendous amounts of steel in this tower because you have this giant lever, all right? Small footprint. For every 10 feet you go up, 1 foot of leg spread. So a 100-foot tower is going to have a 10-foot leg spread. 120-foot tower is going to have a 12-foot leg spread. It's going to have, so you have a 10-foot leg spread, you're going to have 10 feet of concrete below grade also. In a column or in a drilling bell, so you're going to have a column going down with a bell-shaped bottom, 10 feet down. 11-foot leg spread is going to have 12-foot leg spread is going to have 12 feet of concrete subgrade. We'll see couple of different kinds of footings for these towers. So this is going to arrive at your site all in pieces. You're going to assemble it on site. You're going to have a blueprint. Blueprint is going to spec out where all the pieces go, what the footing is going to look like, and then in fine print it's going to be consult your local engineer. 120-foot tower is going to cost up to $20,000. Can you use a used tower? Absolutely. But you're going to find out what are the specs of that tower, what are the lateral loads on that tower, or what is the tower top weight that this tower can handle. And you're going to go to the manufacturer and find that out. This is V15, a 8,000-pound or 11,000-pound machine on a 120-foot tower. This tower is built for that machine. Here is Fran Cherney's 80-foot tower with his Jacobs on top. This is the wind machine that toppled into the spruce trees right here. This is where the crane got stuck. So these all came in sections and were bolted together. And this tower here, this is Butter Eckers. So they built the tower on the ground, and generally you would just pick this tower up, drag it as you lift it up, set it down on the bolts, and you're good. This tower is too heavy; it would buckle, it would damage the pads as well. So it was lifted up with 2 cranes, rotated in place vertically. This crane was cut away, and crane number 1 swung it over in place, dropped it on its bolts. 32 bolts, 3 pads, 32 bolts, 24 bolts. And all the bolts lined up, lowered the tower onto it, spun the nuts on, nuts about this big, spun them on, snugged them up, cut the crane loose. Crane came around, grabbed the machine, lifted it up, put it into place, all the bolts lined up, put the bolts on, snugged them up. Before that, these were all torqued up. These were snugged up. Crane came over, picked up the rotor as a separate piece. In the meantime, they torqued all the bolts on the machine, lifted the rotor up and put it into place. Crane time, a little bit less than an hour. Never will happen again in this lifetime. Never. How much does it cost to get a crane to a site? An 80-ton crane, say. For us, it costs just shy of $500 port to port, just to get to your site. Then it's $175 an hour. So whether the crane operator is working or not, or reading a magazine or taking a nap, the meter's running, just like a taxi cab. And the sooner you can get this guy out of there, the more to your benefit. And a good crane operator is worth every single dollar, whether he's sleeping or not. And I've been on jobs with bad crane operators, and that is not fun. And it's a matter of safety, too. So here is a 100-foot tower, 80 feet of a 100-foot tower, laying down on the ground. All came in pieces. We assembled it. All the conductors are run up the tower, zip-tied down. All the piping is fastened down. All the conductors run. Any monitoring, all the foot pegs are on. Everything you can possibly get on this tower, you get on the tower because it's 100 feet that way. And number 4 copper is really heavy. And we've tried, one time we thought, yeah, we'll just coil it up and then just drop it down the center of the tower. Doesn't work. It gets into a great big knot, and then try to get a big knot out of conductors, 80 feet up or so. Doesn't work. Crane comes in, lifts it up. In this case, we had 20 feet already in place. Get up, bolt it down, cut the crane away, lifts up the machine. There are times when you can pick up both the tower and the machine together. This time there was no room. There was real confined space. Not much room behind this building. Lift it up, 3 people up top, put in 3 bolts, cut the crane away, and he's gone. He leaves. Very simple, down and dirty. This is a construction project. People that do this do installations are forming concrete, pouring concrete, digging holes, trenching, wrenching. And the electrical part, that's just a small portion of the whole big picture. This is a construction project. Anything to add? Yeah, you need to be a jack of all trades. And sometimes you have to farm out some of the portions to it, the digging and maybe the concrete work, but you're going to be a jack of all trades doing that. And there's the finished machine. We had an installation where we took and this is a 100-foot freestanding tower. When we did the 120-foot tower for the Jake, that's a 120-foot tower, 12-foot leg spread. The back 2 legs, say these 2 legs, had a hinge plate on them. So we built the tower on the ground, but it had a hinge plate on the feet, here and here. So we tied on with a crane, 25% down, tied on with the crane, and then we tilted that tower up into place. But that's the only time we're going to tilt that tower up. Once it's up, it's up. So tied on with a 40-ton crane, Jim came out, eyed it up. He's an excellent operator. Tried picking it, lifted the crane up. And just because of the way he had to position himself, he had to position himself at the pivot point. Couldn't pick it. Brought an 80-ton crane, couldn't pick it. Got under it with a forklift, lifted it up as high as he could, and then he could get his boom back far enough and then raise it up the rest of the way. There was a lot of people that had to clean their pants off. I thought that thing was going over. And then it's pulling against the hinges too. Just didn't like that. But that was the machine, the tower, everything went up at once. It was really cool. Guide lattice tower. This is the least expensive tower out there, and it's going to look like it's going to be 3-legged, and the leg spread is going to be about 14 inches, 12, 14 inches, and the bottom 10 feet is identical to the top 10 feet, modular tower. Each section on a thin wall tower is you can lift it up. One person can lift it up, move around, 2 people, what have you. A solid rod. Another type of tower is this SR tower, solid rod. So these are going to be solid columns, solid pieces of pipe going up, maybe or solid round stock, inch and a quarter, inch and a half pieces of steel going up. They're going to have bolted flanges, Z bracing going up. This is on its side, Z bracing, which you're going to climb up, assemble it on the ground, lift it up with a crane, put it in position, and then it stays there. It's guide off in 3 different directions. Guide stations are going to be about every 30 feet or so, spaced apart. Guy radius from side to side. Side to center is going to be 120-foot tower is going to have about a 90-foot, 5-foot guy radius, so about 180-some feet from side to side. Big real estate. This has a big footprint. This is going to be out in the pasture. Can you do stuff underneath the guy wires? Absolutely, but you don't want to follow the lines. As long as you don't follow the cables, you're cool. You can run cattle out there, what have you. As long as you don't run into them with a tractor or a truck. It's going to be really flimsy on the ground, but once it's up and cabled off, you're all good to go. Here is a SR tower, 45G SR, solid rod, flange plates, anchor points, guy stations. Here, tower top adapter. So there's on every tower, every machine is going to have some adapter that's going to go from the machine to the tower. Here, in this case, here's that. Here's 80 feet, 40 feet being assembled. So the crane comes, here's Jim, sets up, lifts up the first 80 feet, puts it into place, and a crew, one person's going to be at the base of the tower with a 4 or 6 foot level up one leg, and all your friends are going to be over at the 3 guy stations, 4 on each station. 4 is better than 2. Can't do it with 1. And they're going to be pulling tension and releasing tension on these cables to get this first section plumbed up. And they're going to plumb it up with a level. And they're going to be using come-alongs and grips to make that happen. So how do you know what kind of tension you need on this one, this cable, and this cable? Well, you're going to measure out the cable length, do some math, and you're going to come up with a number. And that number represents the number of times that you wiggle the cable back and forth in 10 seconds. All right? So if you have more wiggles in the cable in 10 seconds than that number, you're going to put more tension on it. If you have too few wiggles back and forth, oscillations, in that 10-second time period, you're going to release tension. It's called tuning a tower. So you're going to tune the first set of guy cables, all right? Then you're going to go to you're going to tune this set, and the person at the base of the tower is going to call slack, tension, all the way around till you get the cables tuned up, get the tower plumb. Then you go to the next guy section. You're going to tune that cable, and you're going to go to this section. You're going to tune that section. And the person at the base of the tower is going to eyeball up the leg of the tower and plumb this whole tower up. So you're going to plumb 120 feet up, just eyeballing it. Nowadays, you can use lasers or what have you, or a plumb bob you can't use. But you're going to extremely tall towers, that's what they use, or they use a laser. But mostly just eyeballing this whole thing. And it seems ridiculous that you can plumb up 12, 14, 16 sections of tower, but it works really, very nice. You can tell where the wiggles are. In the meantime, crane operator is falling asleep, ate his lunch, and then the next 40 feet can go up. Because this tower is so flimsy, you can't pick all 120 at one time. So you're going to do 80 and then 40. Then you're going to tension the last section of guys, and then you're going to bring up the machine. On the solid rod towers, some of the solid rod towers, you can do both the tower and the machine all at one pick. Not all the time. And it depends on the location, the crane operator, and weather conditions as well. The crane time on this one was over 9 hours. To get it, most of that was tuning up the cables. Big crane bill.
Can you talk just a speck more about tuning those cables? Are you talking about just pulling and releasing? Or
Tuning the cable. The question is tuning the cables. Say that again.
well, when you said that you tune them by seeing how much it oscillates, you just like flip it?
So how do you tune the tower? You're going to grab onto the cable and you're going to pull it towards you. You're going to pull it back and forth horizontally, and you're going to count how many times you can do that in 10 seconds.
How many times you
Yep.
What was the question again? I'm sorry.
The question was, how do you tune the cables? So you're going to measure out the cable length, and you're going to do some math, and you're going to come up with a number, and that's going to be like 5 or 8 or what have you. And that's based on the length of the cable. And how many times you can move it horizontally back and forth in 10 seconds is you're going to get a number. And you're going to compare that number to what your math came up with. So if it's too few, you're going to release tension. And if it's too many oscillations back and forth, you're going to tension that cable. And that's how, and you're going to have the same number all the way around. So it's evenly loaded. Let's see. Another way to bring up these towers, and this is on the tall towers, on the radio communication towers, this is how they build it. They gin it up. They don't make cranes that tall. So here's one tower section. This gin mechanism is clamped to the first section. This is guyed off with temporary guys. And up at the top is a pulley system, so you're going to hand winch this up or use a winch to get these tower sections up. You're going to have a block and tackle system at the base of the tower as well. Thought it would be really, really cool to do this. I was always interested in it until we did it, and one of the worst experiences of my life. There's just cables and temporary cables and guys that you have to mess with. Not a good experience. I wouldn't want to do this. But in some cases, you might not be able to afford a crane, or you can't get a crane in, and this is what you have to do. So you get you and 12 of your friends that may be expendable to do this for you. They won't be your friend anymore.
How long did that one take?
Just 2 sections all afternoon. But then the next year we put up a real heavy, I bet you that was 150-pound tower top adapter up and a 250-pound machine, piece by piece, and did that. Things went much better. We kind of learned some lessons. And sometimes you can't bring a crane in. It just doesn't make sense to bring in a crane to bring down blades. So you can gin them down off a tower as well. So we can use this gin pole mechanism for many different things. Bringing up parts, materials, changing out machines, and not bringing a crane. All this temporary rigging, just not good. Tilt-up towers. This type of tower we're not going to climb. It's unclimbable. We're going to build it on the ground. We're going to build it in this L-shaped position. It's going to have a pivot point at the base. This is the gin, the L part. We're going to guy it off in 4 different directions. So we're going to guy it off 4 aft, which is going to hook up to the gin, and then side to side. Now the guy radius for this one, 100-foot tower, 126-foot tower, is going to be about 45, 50 feet from anchor to center mast, or about 90 feet from side to side. But also then, we need room in front of us when we drop the tower, so we can lay down the whole tower down on the ground, do the work down here. So we're going to need 126 feet forward of our tower. And then if we can bring this up and down with a winch system or a vehicle. If we bring it up and down with a vehicle, we're going to need a long runway also. For a 126-foot tower, we needed a 300-foot runway that needed to be clear also. So when you buy this tower, you're going to buy a tower kit, and in general, it's going to be all the cable, all the hardware and fittings, and then you're going to go to your local pipe store and buy Schedule 40 pipe. And you're going to get couplers. So this coupler is going to look like so, with a piece of flat stock welded to this across the center. Going to have holes drilled in it. This is where you shackle in, and then cables come down off of it. So at each tower section, you're going to have a set of guide cables off. You're going to have to measure those out and tune them also, each guide section. And then you're going to slide this down into the Schedule 40 pipe that you get at the local pipe store. And it's just going to sit in there, compression fit. Then the next section is going to go on top, like so. There are some tilt-up towers that are going to have bolted flanges, a little bit different system. Medium size and price. Here's a 80-foot thin wall tube tower, very nice. Small machine up to like 1,000 watts machine, 47, 70-pound machine. This is a Schedule 40 tower, thick wall tilt-up tower. Here's the pivot point, the gin, the main mast. Here's a 400-pound, 440-pound proven on the end of it. This one, the light-duty tower, 2 people can bring it down. One person to operate the equipment, the other one to keep that person out of trouble. And do spotting. You're always going to have 2 people in case you get in trouble. When one person brings down a machine, the blades can swing around, clip the ground. That's what happened to this blade here. An experienced installer managed to do that. This tower here, this 5-inch tube tower, each tower is rated for a certain amount of weight and a rotor diameter. This tower here was being really pushed to the absolute limits. So Sam Simonetta had the same setup. This is our setup at the REI. Sam had the same setup, same tower, same machine, same everything. And when you bring this tower down, when you bring this tower down, it wants to kick up the top 20 feet or top 40 feet wants to kick up right at this joint. And so what we do is take the cables on the forward side, we grab that guide station, the second one down from the top, and we pull to the side of that, and we pull that kink out of the tower to bring it down flat. This is pretty dangerous. What happened is Sam's tower buckled, and the whole thing came down and smashed. Brand new machine. Only been up in service 2 months. More on that later. So this is a tube tower for an endurance. Do you use this type of tower? And bolted flanges, very nice system. Here's the pivot point. This is the second one that was installed in the United States. Pivot point. Here's some of the tower sections laid out. Now this tower was put up by a crew who's experienced. They do tilt-up towers all the time. They do the 100-meter Met towers. They'll just lay out the pipe, guess at the length of the cables, fly it up in the air, and you have this big snake going up, and they'll tune the tower. And they do this every day, any kind of weather condition. Highly experienced crew. For students, or us folks, you're going to take and build the tower, build the gin and the mast, get that set, and then you're going to do about 40 feet of tower first. Lay it down, put on the next coupling, raise it up, tune that guide station, lower it down, put on another coupler, another set of pipe, another guide station, raise it up, tune those cables, lay it down. You're going to do this process back and forth. Do you build the whole tower, or do you do it section at a time?
No, we build the whole tower.
Do you? And crazy people do that. And then you lay it down, put the machine on, and build and bring it back up. But experienced crews will do the whole thing all at once, minus the machine. Here they are bolting the flanges up, torquing it up. Here's one of the guide stations on the tower. And then they're going to run down to three anchor places at the base of the tower, right over here. There's more cabling. They're setting the gin, establishing this L shape. And then they're going to lay it down and bolt on the rest of the tower pieces. At the base of the tower, the fourth guide station is going to have a giant block of concrete. This is where the gin anchors into is permanently affixed to 364 days a year. Here's a guide station right here. They're tuning the cabling. Winch operating off the truck. These guys, this is what they use all day, every day. They use this all around the United States, putting up Met towers. This is what they use. So they put on all the tower sections, raise it up, and this is what you get. This huge snake that goes up in the air. And then they'll start at the first guide station, plumb up the first section, tune the cables, go to the next set, plumb it up, tune the cables, and go on, so on and so on and so forth. How long does it take to tune your towers?
They can usually install the tower in less than a day.
Yeah.
From start to finish.
Yep. Group of students, couple of days.
Yeah,
involved.
we actually use a professional tower erector who's been in the tower. They've done cell towers and stuff for years, so they've had 17 years experience. So they actually have taught the endurance crew a few things too. But
yeah, same thing here. This crew does Met towers, 100-meter Met towers, and a highly experienced group of people. What's the name of the company? Do you know?
Midwest Underground Technology.
Midwest Underground. Cool. And then they lower down the tower, and then put the machine on. This is the endurance. Bolt it to the tower. Turbine conductors come down through the middle of the tower, come out of this inspection hole. Up tower conductors come out of that inspection hole, and then they connect them together. Blades on, tail on. Raise it up. And then you're in business. This is that 5-inch Schedule 40 tower that I was telling you about. We're going back there now. Relive that moment. Here's the base of the gin right here. Turnbuckle, fixing that gin down to the block of concrete. We also have a winch over here behind Mike. First time we laid this down for the first, we didn't have the winch when we installed this. Put it up with with a vehicle, got the winch. First time we did service work, we lowered it with a vehicle and then tried to pick it with the winch. And something happened with the motor. And we got the greatest forces on this, greatest weight on this tower, this whole system, is the first couple feet. And once you get it past that point, then it gets lighter and lighter. All right? So we're trying to pick this thing and started smoking the motor. And we're like, Jesus criminy. So it was like, well, let's keep going. And kept going, got it about 10 feet off the ground and had to shut it down. Then what do you do? So we cable clipped all the cables in the block and tackle system together, released the winch, and got a truck on there and did the rest of the pick. So you have to have a backup plan. What are you going to do? What if something fails? You got to have some sort of plan. Light duty towers, 2 people. This type of tower, we need about 6 people or more to bring it down. So here we are. This is where it likes to buckle, right in this section right here. So we always pull tension on that section to bring it down flat. We're always standing to the side. We're out of the way as this tower comes down to pull that tower straight and bring it down flat. And mind you, only the forward cables are going to go slack. The rear cables are going to be on the gin, and the side cables are going to be affixed to the anchors, right? So we're going to have this huge cheese slicer, this huge hinge that comes down. And that's what happens. So we always bring this down in July, no wind, no weather, every time we bring this down. Except for, let's fast forward to November. We had, this is the slip ring unit for that machine. We had trouble with, we had a fault show up in the inverter. Something was wrong. We troubleshot the system all the way over to the tower base. Everything checked out. So there was a problem somewhere between the base of the tower and the machine. And I didn't believe it, but Josh says, it's somewhere in that tower section. And what actually happened was chafing on the tower shorted out the conductor to the tower and shut down the system. Saw a fault. So we hired this extremely experienced crew to come out, and they've done hundreds, if not thousands, of towers, brought them down, tilted towers. And because, mind you, there was, we're pushing the limits of this tower, all right? This is a downwind machine, pushing the limits of this tower, and there's some quirkiness of this whole system. So the wind was coming from the north-northwest, from this direction. It's a downwind machine, so the weight of the machine was downwind of the tower. We're trying to fall it to the northwesterly direction. So this whole tower is over center, and you're going to pull on the forward guys to get this tower to fall forward and fall against the cabling, the block and tackle system, all right? Get it to start to fall. And as that happened, so the crew pulled the cabling forward. The downwind machine, the weight of the machine turned upwind. So the weight of the machine went forward and upwind, and at that moment the tower buckled and the whole thing came down. Just incredible. Lesson learned, pushing the limits. So the only thing difference from November 22nd to every other time we took down this machine was the wind. And we were operating out of the parameters of this tower. If this was a one size larger tower, would have been fine. So that was a $30,000 lesson. This is Sam's machine. He had the same problem, same thing happened. This is the blade root right here. Bent that up, bent the drive shaft. This is where the pancake or axial generator is, same as that thing right there. On a larger scale, very compact generator. 2,500 watts, about this big around, and about that thick. Not very thick at all. So here's a magnet rotor, stator, that's where the coils are, and then underneath this cover is another magnet disc. bent that. There's a bunch of stuff here that had to be sawn off, broken bearing. Conductors through the center of the tower. This is a light duty tower, very nice. Made for what it's used for. Another way of getting power down from the machine to the base of the tower. Remember, we have these slip rings. Is one method. An old school method is to just run a SO cord from the top of the tower all the way to the base of the tower. Put cord caps on the end. Twist lock. Take the cord cap apart, take the twists out of the conductor, put it back together every 6 months. About 12, 14, 16 twists in the wire. And that's just, that was one method used up till just 5 years ago with some manufacturers. Mm-hmm.
What's the frequency and scope of maintenance one can expect with the towers once they're installed?
Every 6 months you're going to inspect all the fasteners, all the fittings, all the cabling on that tower. Before you climb it, then if you have to climb, then you start climbing. And that's just a part of your service work. So, is there stuff you have to do to it? If any of the galvanizing rubs off, we paint that over. We're always checking the bolts and fittings on the tower. Always checking the conductors on the tower. Stuff like that. It's all a part of the 6 months service and inspection. Mm-hmm.
So one of the every 6 months is just using binoculars?
No, every 6 months, if you have to climb that tower, you're going to climb the tower.
So the unclimbable, you said you only bring down in July.
That particular machine we would bring down in July. Yep. Mm-hmm.
But that 6 months later.
Yeah, I know. We're on the 12 months regime.
That's one advantage to the tiltable towers, wouldn't you say, is that you don't have to climb them to do maintenance?
Oh, absolutely.
You just drop them down?
Yep, absolutely. You just drop them down. You and a couple of friends, you drop this machine down, do the service work on the ground, and then pick it back up again. And that's a big advantage to people, especially people that don't want to climb. And it's not as expensive as a freestanding tower. Yep, absolutely. And this is just one instance, that machine shouldn't have been on that tower.
So, if this is on your homeowner's insurance, and if this thing crashes on its way down, is that covered?
We're still dealing with that. The insurance just here from our crash turbine, we're still dealing with the insurance company.
After you tune a tower, do you got to retune it every time you raise and lower it?
No, it should be set. However, we did tweak one of our towers. We did tweak once, yeah. But we're going to walk out to that tower before we even climb it or bring it down. We're going to check all the fittings at the base of the tower, all the anchor points, make sure none of the cable clips have slipped or anything. And then we're going to go to the base of the tower, eyeball it. How plumb is it? Is it okay? Yep, you can always do that. There has been instances where, and you're going to have safeties involved, where something happened, like somebody took a safety off and a turnbuckle backed off, and it was just hung on. The turnbuckle was just on by a couple threads. So anything could happen, Could be hit by a car, a tractor, what have you. Yeah.
Out of curiosity, your manufacturer of your machine is going to give you the weight of the device. Are they also going to supply you with wind load information so you can buy the correct size tower?
Yeah, so the question is, are the manufacturers going to tell you what can go on that tower? Yep. So each tower is going to be spec'd out for rotor diameter and weight. Yep, they're going to tell you exactly what weight and maximum rotor size can go on their tower. Yep. Doesn't matter if it's a tilt-up tower, guide lattice tower, freestanding tower.
Okay, so you're saying you actually need to go to your power manufacturer rather than go to the machine manufacturer.
They're going to work hand in hand. So you're going to the manufacturer of the machine and the manufacturer of the towers are going to work hand in hand. How many towers can go on that endurance? Is there? Do you know? Can go with that endurance?
Oh, we actually sell it, that turbine and tower together.
Mm-hmm. Okay. So you have to match that tower and that turbine together. That's
We
it.
sell different heights.
Yep.
We sell a specific tower.
Mhm. Okay. Anything else to add?
We buy it from the manufacturer too, because that just takes liability off of us.
Yep.
Let the manufacturer do it.
And Berge will spec out the tower that goes with their machines and all this. Yep. Any other questions? Yes, sir.
What's your tower of choice? Do you want one that you can climb up and get to easily, or one that you have to drop down if you want to do anything with the system?
For my dollar, I really like a guide lattice tower. They're really flimsy when they're horizontal, but once you get them up and in place and guide off, they're rock solid. They're easy to climb. I think freestanding towers are hard to climb. You have to high step it, and they're really slippery. The galvanizing on there is real slippery. I dread every time we have to climb our freestanding tower. And you get up on the top there, 120 feet up, it's wiggling around. It just gives me the willies. But a guide lattice tower, just rock solid top to bottom. Really nice. How are we doing on the streaming thing? Guy in the back. Okay. Do we have to take a break soon? Okay, sweet. Any other questions? Yeah.
You mentioned earlier the issue of wire size when related to long runs.
Yeah.
Is it possible to transform the raw power down up and then down again to reduce your wire size for the run?
Say like inverted at the base of the tower, is that what you mean?
Well, say like the electric company doesn't send 240 volts to your house, they send 12 kilowatts to your house, and then they transform it down.
Sure.
And that keeps their wire size and their transmission lines down. Okay, can you do the same thing with raw power, or is the raw power too low of frequency?
But we have machines now that are running at 350 volts. So I don't think to bump that up and then take it a longer distance. Yeah, you can do that, I suppose. We were talking about doing that for that one off-grid situation, but that was 24 volts. That low voltage situation. And then one thought was to bump it up and then take it over to the battery packs. Yeah, you can do that. Yeah.
Well, the problem would be the size of the transformer, because the lower the frequency, the bigger the transformer.
Right, yep.
And your raw power may be very low frequency.
Yep. I don't know. I'm sure somebody's done that. There was an instance where they took a high voltage machine, and the closest they could, this was in Alaska, and the closest they could get to a good wind site was like half a mile, and they just bumped up the conductor size and took it over there. But they had greater than 5% line loss, though. But that was part of the deal, that they did the best they could. I don't know of anybody that's done that, but I'm sure somebody's incorporated a transformer in there somewhere. Another way would be to transform at the tower base, and then take it over. But you're running at only 240 then. It's a horse apiece. But then you have electronics out in the weather, and then you're dealing with minimum temperature also, where some components can't handle sub-zero temperatures. And that's an issue up by us recently. Other questions? How about off-site? Nothing? How about in here? Okay. What do you deal with tilt-up towers and monopoles? And can you tell us just briefly about monopoles in your experience?
Yeah, monopole is it's just like putting up a street light pole. Now they're getting taller with the monopoles, and for shipping purposes and costs, they're actually coming in pieces. They'll actually slide into each other. They're a lot easier. Like the Windspire here, the bolt kit is that the hinge kit's actually built onto the bottom of the monopole now, so you can tilt it up and down. Where like the Skystreams, they're not built on there. It's another kit. You have to bolt onto that to actually take it on and off, and then put the hinge plate kit on there. I like those a lot better. The guided towers, we did a couple of those big ones, and they are scary. So most of the ones that we do is the monopoles and put up. So, but they're a lot better. The only thing I'd have to say add to the guided towers is if you go to your local supply store, spend the money for some paint and paint the pole, because a matter of a few weeks the thing's going to be rusted. So that's the only thing I don't like about that is that pole. A lot of guys will put those things up and not even put a coat of paint on them. So now you got a $20,000, $30,000 system there, but the pole looks like it's been there for 100 years.
Yeah,
So-
or get galvanized pipe.
Right,
Yep.
right.
Yep.
So, okay.
Yeah, I think it's well worth the investment to do a little paint job. Nice cosmetics, yep, absolutely.
I have a question on the Grange County.
Yeah, go ahead.
You've talked about on the towers on the loading and matching them to the machine. Do they have like a specification where they do like a maximum wind load on an already existing tower after it's been erected?
The manufacturer's going to have that all spec'd out in their blueprints of what ice loading, lateral thrust, this, that, and the other thing. Is that what you're talking about?
Yes, like if you had like a severe thunderstorm, you know, would it actually really survive like a super strong wind gust, say in excess of 65 or something?
Yeah. As long as you stay within the specs of that tower, yeah. And, you know, all this stuff is rated for 110 miles an hour or greater. And as long as you operate within the parameters of that tower, you're good. Once you get above 110 miles per hour, then you got other issues going on, like sheep flying through the air and metal and what have you. So which could hit your tower and buckle your tower, absolutely. You know, things flying into it. But this is, you know, after 110 miles an hour, you got other issues going on. But yeah, and in that apples to oranges article I told you about a long time ago, that article will provide lateral thrust information for specific machines, and that's based upon rotor diameter. And we'll see that in just a little bit. We talked about FAA. I think you had questions about this earlier. Somebody had questions about tower heights and FAA, living near airports. If you live within, 4 miles of an airport, whether it be a dirt strip or a regular one, you need to file this piece of paper with the FAA. And it's just name, rank, serial number, longitude, latitude, and then the FAA is going to look at that. 99% of the time, they're going to say it's okay. The other 0.5%, they're going to say, well, you may have to move it this way or that way or what have you.
What about individual like hospitals and helipads? It's not an actual airport, but there's a lifeline that rolls through there.
Yeah, you would file that piece of paper. Yep. When do you need lights on a tower? At 200 feet or greater. 199 don't need lights. Guess how tall the cell towers over in my neck of the woods are? 199 feet. You look like you had a follow-up.
Where do you get a hold of the FAA to
Bingo. Here's the number right here. If you go to renewwisconsin.org, that's in the websites I gave you earlier, renewwisconsin.org. Go into the small wind toolbox, and that has that document. You can download it and get that information. Yeah.
At height, blade height or tower height?
The 200 feet? Blade. Yeah.
I wanted to add to that tower height. Just because it's 200 feet doesn't mean you're going to make it. It's like in Valparaiso, the airport actually sits down a little bit lower. In a lot of places where people wanted wind generators, 90 feet they were above the 200-foot mark of the elevator there, or the airport. So you have to keep that in mind, your elevation to where the airport is also.
What about my crazy neighbor with a grass strip he uses twice a year? Does that count?
Yep. Includes strips that are used for crop dusting out in the field, you know. Includes those as well. Yep. Never knew about this. We have a strip just half a mile away. Never even thought about it. Never filed this piece of paper. Nobody got busted. But the FAA could definitely come in and say, no, can't do it. So you're going to file this piece of paper, err on the side of caution. Foundations, real quick. We have so we're going to have this giant lever sticking up in the air, and the longer the lever, the less force you need on the side to do a tremendous amount of work. All right. So if I picked out the apples and oranges, has this lateral thrust data on it, and then we have turbine weight. We know that, and so I picked out the lateral thrust information for a Jacobs long case. That 14-foot rotor can have up to 800 pounds of force of wind loading on that rotor, all right, maximum. And so a 14-foot rotor, that's in general. So we have a freestanding tower, 3 legs. So on one side of the foundation, we're going to have force times distance. Distance is 100 feet. 80,000 foot-pounds lifting up on one side, and a bunch of energy pushing down on the other side of the footing. So we're trying to wrench out. We have tension on one side of the footing, compression on the other side of the footing. All sorts of forces going on. So the longer the lever, the more work you can do with less energy input. Here's Corey Babcock's tower. He lives over in Lewiston, Minnesota. He was actually doing some work for us. His mom called up and was like, Corey, your tower fell over. What's wrong with this foundation? I don't know why he did what he did, but he did what he did. And he works in the wind farms, by the way. So Corey's foundation goes something like this. It may or may not have been below the frost line. Even if it was, the base of it, what can happen? Frost gets underneath it and just heaves it out. How should it have looked? Opposite direction. Should have been this way, or something like that. Below the frost line, frost can't get under it and heave it up. There's a technique called drill and bell. You bore down, and this is all in the specs of the tower. It'll tell you all these specs, whether you're doing a pad, drill and bell, what have you. So you're going to drill down with a 24 or 36, however many inches bore. And then you're going to cave in the bottom section of the hole. The base is going to be below frost line. Here's the frost line. Then you have this soil cone that's going to help. The weight of the concrete is going to help it keep it in the ground, or is going to keep it in the ground. The stickiness of the soil is going to help it keep it in the ground too. You have this soil cone that's helping it to stay in the ground as well. But mostly it's the concrete. So Corey could have done a better job of that. This is a pad and pier. We tried doing a drill and bell at this location and lined up somebody who knew exactly what we wanted, had the right size bore. Told him what our address was. He's like, "Oh, Custer Hill? Not coming." We have rocks the size of fist up to Volkswagen size. Just wouldn't come out. So we had to do a pad and pier. 8 feet down, 2 foot thick pad, columns coming up to the legs. Did the same thing down on the Jake Tower. That was 12 foot deep hole. This is about $2,000 worth of material. On the Jake pad, I think it was about 28 feet from side to the base, to the point. $10,000 of material in the hole. Can't even see it. Not even the labor. $300 of labor in it. And it gets backfilled. You never see it. Yep. $2,000 in the hole. Here's the type of footing that Corey should have had, or a drill and bell. If we did the same thing for that, for this, if we could have done this in drill and bell, would have dropped the price down to about $1,100 of materials, so about half. For a tilt-up tower foundation, we're just going to, tilt-up tower is going to have 3 anchors of these dead men, 3 of these dead men, a center pier, and then a big block of concrete at the base where the gin hooks up. And this is just, you dig down below frost line, it's going to be what, about 3 foot by 6 foot by a foot and a half thick. Then a center pier or about 5 yards of concrete. Guide lattice tower, same thing, but one less anchor, less than 3 yards of concrete, involved in this process. Price differences, guide lattice, far less concrete. Have to buy a minimum load for that one. Footprints of various towers. Freestanding, the smallest, most compact, and tilted tower, the biggest footprint. Any questions off-site?
Jasper County's here. Got one question. Online, can't seem to find much on towers. I can find a lot on wind generators, but then the tower is pretty lacking. Do you have a good source for finding manufacturers of towers and seeing the different specs and things?
Roan is a big manufacturer of towers. What are some others? We got Roan. Yeah, Roan. And there's a bunch of manufacturers out there, and I can't pull anything off the top of my head, but they don't want you to know what those specs are because they're in the communication business, and we're crossing over to the wind side. So we're using, in many cases, not all cases, communication towers to do these applications. Not all the time, but most of the time. And so you're going to have to go through a dealer to get that information many times, or look at ARE. They make a tower out there. Abundant Renewable Energy. They make a nice tower. And there's a new tower I just found out about. It's a solid rod freestanding tower that has a real 120-foot tower, has a 4-foot base, extremely compact. Lots of steel, though, to hold that up. Lots of concrete in the ground to hold that up. Are you in a kitchen? Are you in somebody's kitchen?
That's their center here. It looks like a kitchen.
Yeah, that's cool.
It was the old REMC test kitchen at one time.
That's cool.
Back in the 50s or 60s.
Cool. Anything else? What other questions? I can't remember the name of that tower that has the 4-foot spread. Can't remember. It's. I didn't write it down, so I can't remember. And
how do you spell that, Roan?
Roan, R-O-H-N. They're really, really good reputation. Lots of good stuff out there.
Are the towers and turbines such, specialized businesses? That's why they're not sold together? I mean, why isn't there a manufacturer that does both, or is there?
I think Abundant Renewable Energy makes a tower for their machines. That's the only exception I can think of. Oh, you?
We provide both.
Yeah.
Like you actually buy the turbine and the tower from us. They're manufactured in New York by a tower manufacturer, but to our specs. So, and I think part of the reason is just because you got engineers that are great at designing turbines. You got other people that are great at designing steel structures. So why not outsource and save yourself some money?
And these are small companies again. I don't know. I don't know the answer to that question. But, it's off-the-shelf stuff, too. If you can hook up with somebody that's doing lots of towers for, like, cell phone or communication, you can buy an off-the-shelf tower at a cheaper price than these small batch type of dealios. Well, anything else? One more question?
Got a question from LaPorte County.
Yeah.
If I may, I had a question back on the generators and before we got into the towers. Question I got on these direct tie-in AC producing units. How do those work with backup generators when the power goes out?
Okay, so we're going to have the wind machine tying into the inverter tying into the breaker panel, right? So if we lose utility power, we're going to physically, can you hear me?
Yes, I can hear you fine.
The inverter is going to physically disconnect from the utility, and we're down. So we add in a backup generator, right? And that's going to have a transfer switch, and you're going to physically disconnect that whole system away from the utility, right, with a transfer switch, and incorporate the generator. And that generator is not going to see the wind machine. The wind machine's not going to see that generator because the inverter is physically disconnected from that whole system. It's upstream of the breaker panel. Does that make sense?
No, not. Question I got is,
it won't be Go ahead.
If the wind turbine is still going, the power goes out. Obviously, the wind turbine can't move because it's a grid tie-in. It's not produced because it's grid tie-in.
Right.
But then the generator comes online. Does that turbine read that energy through the box, through the service panel, and come back online? If so, what happens to all the energy being produced?
Okay. On your transfer switch, in your transfer switch where you have your emergency loads, is what we do is we'll actually, at customer request, we'll put it on the emergency load panel. So it's still, in a sense, backfeeding into the grid when the system's running. But when the power goes out, and most people now have a natural gas generator, when the natural gas generator kicks on, then it sends power back to the wind generator. The wind generator kicks on. If it's in high wind, a lot of times it'll put the generator down into idle. A lot of the newer generators go into idle if you're producing enough electricity.
You're setting up a false grid in a sense.
Right.
And the inverter will only engage if it sees utility grade AC. So if you have a modified
Gotta be a
sine
good
wave
generator.
it has to be a pure sine wave generator.
It won't work on the Generacs. They won't run on those.
Yep. So short answer is, if you can set up a false grid with a pure sine wave inverter, bloody blah generator, you could theoretically make that wind machine work. Theoretically, yep, sure. And it sounds like from this gentleman that you can do that. But you're setting up a false grid. Does that answer it?
Yes, thanks.
Okay. Now we're going to go into wind resources, quality and quantity. Quality and quantity. Okay, so we have the wind. We know that it's generated by the solar power. The sun is heating up and cooling, heating up air masses, and they're cooling down. So we have this expansion and contraction of air masses. We know and can predict prevailing wind directions seasonally. During the wintertime, our prevailing winds, our strongest, best winds come from the north-northwest, where I live. If you live on the Door County Peninsula, they're going to come from the southerly direction. What is the prevailing winds here? Westerly? Northwest? So each area is going to have a different or slightly different prevailing wind. We know that there's going to be seasonal variations in the wind energy, wind resource. Strongest in the spring, winter, and fall. Those 9 months, less in the summertime, virtually zero. And it's going to vary from year to year as well. We're going to have good years and bad years, and it's going to be cyclic. And it appears we went through a really bad period. Now it looks like we're on the upswing of wind energy, getting some nice winds. We also know that there's daily variations, dawn and dusk being the lowest points. Seasonal variations, ours varies from 9.8 to 11.2. V cubed. Difference between the worst month and the best month, 86 feet, 86 feet. 11 miles per hour versus 7.5. Almost 1,000 units more power. We're going to have, if we can just increase just 1 or 2 miles per hour, we can maybe downsize the machine that we need. So we're going to, back in the day, when I say back in the day, as recently as a year ago, we didn't have some of this information I'm going to tell you. We would look at these colored maps that NREL came out with, or states came out with, and we would go to airports and look at their data, what kind of wind speeds they had, and then we would go to the site and go with our guts. Now we have web-based tools that we can use and put in our longitude and latitude, put in our height, and get wind speed data from virtually any height. And even if it's not at our height, if we can get information from the same longitude and latitude at 2 different heights, we can mathematically calculate out the wind speed at any height. Okay? Now we have all this web-based information. Here are some of those sites. AWS True Wind. You go to their website. These are the folks who, I think it's awstruewind.com, I think.
We've got that on our Renewable Energy Extension website, the link to awstruewind.com.
Oh, very good.
Yeah.
Can you pull up just the map, or can you get into the map?
It goes into the Navigator tool.
Okay.
Yes.
Cool. And AWS True Wind is mapping out all the United States, actually all the world, and it's mostly for utilities. You know, utilities use this for prospecting, first look, first blush, but we can use it for our purposes as well. It used to be that you could get most or all the states that they had information on. Now they're getting, it's proprietary, and maybe your state owns it or maybe not. I think Indiana can get access to their map. We can get access to our map, and if you're in the club, you can get the DVD where you can load it up on your computer, and you can go into the map and put in longitude and latitude, or click on a site and get information from it one click away from where that point is, and it'll give you all sorts of information if you're in the club. I don't know if Indiana can you guys, you 2 installers, have you seen that for Indiana? Is that available? Okay, it's really cool if you can find it. Some of that stuff is just proprietary information.
I was going to say Indiana has a GIS mapping tool that has that information layered in there.
Where can you find that information?
Well, you can start at in.gov and get there that way. If you Google Indiana GIS Atlas.
We also have that linked on our renewable energy website.
Okay. What's the Purdue website there?
It's a very long, and so I would prefer to just Google Purdue and renewable energy, and it'll come up. But it's extension www.extension.purdue.edu/renewable-energy. So anyhow, yeah, just Google Purdue and renewable energy. We've got links to those tools as well.
Excellent. So another resource you have in your toolbox. So we're going to take and look at these different sites, get information from those for our specific site, compare them, make comparisons. So we're not going to get consistent information from one site to the next, but it's going to be close. And then we're going to take and look at how good are those numbers. So we can go to AWS True Wind, we can go to Google Purdue Renewable Energy, go to that GIS site. And another one that I like to use, and I have to Google this every time, it is First Look.
And they actually have varying heights on measurement there at First Look. Is that correct, Clay?
That's correct.
Yeah.
And AWS True Wind, you go into the Wind Navigator, what have you, and they have information at 100 meters and 80 meters, I believe. And then you click in, you zoom in and click. Is that correct?
Yes. Yep.
And then what about Purdue Renewable Energy?
The GIS map is it's a little different, and it's not quite like the Google Earth.
Mm-hmm.
The AWS True Wind tool and First Look Wind would be a little more like Google Maps.
Mm-hmm.
the IN.gov GIS map is a different tool, and it's a little more intricate than what maybe an innocent bystander would take a look at. It's a GIS tool. But first look, they do look at 60 meters, I believe.
20,
20, 80,
20,
and 100.
60, and 80 or something like that.
Okay, but I know that they've gone to lower heights than what the AWS True Wind is, and so
Yep.
that makes you can get a little lower to the ground.
Yep, more applicable for our situation.
Absolutely.
Yep. And what happens when we get closer to the Earth? Slows down. We have all this friction out there. We have trees, crops, buildings, cities. It's dragging down our wind resource, and as we get closer, that's going to drag it down even more. So we're going to look at these, get information from AWS True Wind, IN.gov, Purdue Renewable Energy, First Look Wind. NOAA has information under several different layers, and NASA has information several different layers also. But we're going to take this information, this web-based information, they're going to give us a number. I checked out just this area. I just clicked on an area that was north of town, north and a little west of town, on the edge of town, and I came up with about 11 miles an hour at 100 feet. Does that sound fairly accurate? I think that's a good number. And that's a good number for residential purposes. Up in my neck of the woods, we use 10 miles an hour average annual wind speed. And so it varies from place to place. And so we're going to get a number for the northwest side of town, outside of town. I got the average annual wind speed of 11 miles per hour. So if we picked up here, went out to that site, and then we're going to look at the environmental indicators. What is the environment telling us about these numbers that we get off this website? Is this a good number or is this a bad number? Griggs Putnam had way too much time on their hands, and they came up with this chart. And they said they recognized or realized that the environment had an impact upon how the vegetation grew. So lone coniferous trees that don't lose their needles or leaves throughout the year, there's a deformation in the growth of these trees with increased wind speed equals increased deformation. And this is what the chart they came up with, fairly accurate. Here is this is at 6,000 feet on a mountain. Here is definite deformation of growth. No limbs growing upwind. Prevailing winds, the deformation is going to tell you where the prevailing winds are coming from. So the winds are coming from that away. And so we have the trees are growing, the branches are growing around the stem of the tree. Here, just down the road from there, is not only the limbs growing downwind, but also we have a throwing of the stem as well. Tremendous resource here. And guess what? There's a utility scale wind just down the road from here. Good wind resource. So, and here's my lone white pine on the corner of the property. Upsweeping of the branches upwind. A little bit of parting. Just subtle. You have to walk all the way around this tree to see that. And as you're driving up and down the roads of this state, or any state, you can see this taking place on fence rows or lone trees or what have you. And deciduous trees, trees that lose their leaves during the year, are going to tell you something too. So here's the stem of the tree going up. Prevailing winds are coming from my right. We're going to have the crown of the tree is going to be dense and close to the stem of the tree. And there's going to be an upsweeping of the limbs, and the tops of the limbs are going to looks like little fingers or smoke going downwind. All right, densely packed on the upwind side. Downwind side is going to be more of a natural, looser crown. You can see this driving up and down the road. When you go home tonight, check it out. Especially if you live in north and west of this area here. Where's the wind machines at? Where's the utility scale winds at? North and west from here. Check it out. Snow fence. You see snow fence, there's something going on. Somebody's trying to make the wind do less work. Right? Snow drifts are going to tell you the prevailing winter winds as well. That's when we can get our best wind production, during the wintertime. And we're going to need to know what is the prevailing winds so that we can sight this wind machine upwind of any obstacles that might rob our fuel. Dirty snow, shelter belts. Farmers build shelter belts around their buildings. Why? To slow down the wind. There's some sort of resource there. This is Fran Cherney's place. Remember, this is the Jacobs that has all the problems. 1980 vintage. Nothing between him and the Mississippi. Absolutely flat. Good wind resource. Shelter belts, drifting snow, more drifting snow, and more drifting snow. Dirty snow, tattered up flags. Wind machines, other wind machines. How many people saw a wind machine coming in today? Where is it located? Little farm. Did you ever see it before? Have you ever seen it there before? Okay. What about you?
Highway 26 going towards Kokomo, about a little bit more than halfway towards here, so about 20 miles out of town.
Okay. Anyone else see a wind machine? Yeah.
On 31, just south of Kokomo, there's 4 or 5 smaller.
Oh, yeah.
units.
Yep. So people that own wind machines know what's going on. Even if they don't have data collection, they know what their wind speed is, and they know what the production of their machine is as well. Good source of information. We have, before we had this web-based tools, we had 4 or 5 calls every year. It's like, what's your average annual wind speed? At what height? And within the county, people would just call up because we're the only place that had data collection at that time. Also, we can go to the airport, call up the airport. Hey, what's your average annual wind speed? And guess what? They collect that information too. But they're going to collect their information either from 33 feet or 90 feet or both. The evolution of wind maps used to be based on topography, best guesses. And, Wisconsin, Indiana, same thing. They took the obviously good places that, yeah, that's good. Central part of the state, oh, that's terrible. And as we got more information, the maps got better. Here's Indiana. Obvious good places. Bingo. Bingo. Where's the wind farms? Well, right here. Is there anything over here? East of Lafayette?
There are probably 5 or 6 companies that are trying to sign up leases, but they aren't actually built yet.
Mm-hmm. When I was coming down, I saw lots of monitoring towers. They had the orange balls at the base of the tower and then up near the top. Lots of monitoring going on out and around this neck of the woods, down I-65 when I came down. Yeah, so the wind farms are going to go to the low-hanging fruit. Now they're going out from those areas, prospecting for wind. Here's the AWS True Wind map. Hard to read. Go into the website. A little bit easier, when you print it off. Here's the legend down here. More detail to that map than this old NREL map. When the AWS TrueS is taking military information, NOAA information, satellite information, and then they're computer modeling it, and then they're validating it with actual test sites, like seeing how accurate that is and then tweaking it. So you got a pretty good product there. Airports, again, at 33 or 90 feet. Here's a data collection point from the DOT. Here's the anemometer up top. And the information that you get is only going to be as good as the place that it's collecting. Sam Simonetta, one of the best, a really good wind site assessor, was collecting some of his information was coming from K.I. Sawyer Air Base up in the UP, and it wasn't ringing true with other sources he was getting. So he went to the actual site to see where they were monitoring the information from, and the data collection was taking place on the leeward side of the control tower. So how good was that information? Not very accurate. This is at an Air Force base. Here's information from various airports. Eau Claire, we have 9 miles an hour, 9.9 miles an hour. At Truex, we have 8 miles an hour and 11.2 miles an hour. Why the variation? Height. Yep.
What are the heights usually for
33 and 90 is the data collection points for airports. And if you have two pieces of information from the same tower, different heights, you can mathematically calculate out what the wind speed will be above that and below that.
One thing, Clay, too, we've done some analysis for some different companies on that have actually collected data for on wind speeds in their areas, but that height really does play a role in evaluating if that site is suitable, because there can be some interference from buildings and trees, and we've had a situation like that where the AWS TrueWind and the other tools look different than the actual data, but the monitoring anemometer was only about 20 feet off the ground.
Mm-hmm.
So those are some really critical things to take a look at and really analyze and be critical of some of that information where there may be some obstructions from trees and buildings. So you'll talk about that later, I'm sure.
Yep, and that's why we're gathering up as much information as possible, getting as many tools in our toolbox as possible so we can see where these variations may be. And then we're going to go to the actual site and see what the site is telling us. And, I talked to Dave Blecker, 7th generation wind, and one of the best prospectors out there, and he told me a couple stories. One of the first story was he went to a site, thought it was going to be good, and in fact, great. And he spent thousands of dollars to do a computer modeling of this site, and it came back saying this is a poor site. He took that information, went to the site, kicked around, looked at what the vegetation was telling him, and he's like, no, that's wrong. Put up a monitoring tower, and he spent thousands of dollars and got the wrong answer. Then there was another time he thought he had a good site, spent thousands of dollars to have computer modeling done, came back saying it was a good site, put up a wind machine, and it was poor. So I was like, well, what's the answer? And he's like, well, gather up all the information you can, go to the site, tell it, ask, see what's going on. What is the environment telling you? What are the indicators? You gather up as much information you can, go to the site, see what it's telling you, and then guess. And go with your gut, and he's like, that's the way it is, You can't put up a monitoring tower all the time, and it just doesn't make sense. But for our purposes, residential scale, I think we have enough information out there to make a good, informed decision. Okay. So what kind of information are we getting off of this data collection place? By the way, here's the anemometer right here. Probably not very accurate. What about this one? Here it is right here, if you can't see it. Probably not so good. So we're going to take all the information we can, verify it, and go with your gut. We're a little bit beyond waving a dead chicken over your head, but things are getting better. Quality of the wind. So we have this wind profile racing across the land and hitting objects. It's going to be drugged down through friction at the base, and as if we take a slice of the wind, these arrows indicate direction, and the longer the arrow, the greater the force in the wind. So as we go higher, longer arrows, more force. When we come up to an object, we're going to have compression before the object. And as we pass over the object, we're going to have a distortion of the and tearing apart of the wind profile. We're going to have eddying. We're going to have the wind going opposite directions all over the place. And then in the wake of that obstacle, the profile is going to straighten itself out again and reestablish itself. So, we're not utility companies. We're limited within our 10 acres, our 20 acres, our 40 acres, or 5 acres. And that's what we got to deal with. If we're not a utility company, we can't go down the road and find a better spot. So, if we know where our prevailing winds are coming from, if we know the height of these obstacles, if we know how the wind operates in the wake of those obstacles, we can plan ahead and get separation from those obstacles by either going vertically or going horizontally upwind. All right? The wind obstacles are going to cause turbulence, rob our fuel, and cause our machine to start hunting around for for the wind. When a machine starts hunting around for the wind, that's when wear and tear happen to our machine and shorten the life of it. So, if we think about wind operating like water operates, we can have some sort of visualization of this wind, how it operates as it goes over objects. So in general, if we know the height of an object, the tallest object in our 40 acres or 5 acres, what have you, if we know h, we can assume that upwind, that we're going to have a disturbed zone about 5 times that height upwind, and about 30 times that height of that obstacle behind or downwind. So we can use this to we can have some strategies for sighting our wind machine. Can we sight within this turbulent zone? Yes, we can, but we have to get above it. And if possible, upwind of the obstacles, if possible. If we can't get upwind of the obstacles, if we can get as close to the obstacle as possible, but above it, it's to our advantage. We don't want to be in this turbulent zone. So the general rule of thumb is this. We want our wind machine to be, we need it to be at least 30 feet above everything within 500 feet of the lowest extension of the blade. So if we have, this is say a 3120, that blade length is 15 feet, it has a 31-foot rotor, say 15-foot blade length, minimum of 30 feet separation, and this is a 75-foot white pine. What's our minimum tower height? Absolute minimum tower height. 120 feet. Absolute minimum. What else do we have to consider with that, say, tree heights? Trees grow. Yeah. Another story. There was a fellow who had a Christmas tree farm, put up a wind machine, and I think it was on a 60-foot tower, real short tower, only a tower you would see in Kansas. And he got out of the, worked fine, machine was excellent, got out of the Christmas tree business, and the trees grew up. And he called the wind installer. He's like, hey, my wind machine is just not working like it used to. Guy goes out there to check it out. Well, the trees had grown up closer to the turbine and was robbing the fuel. So over a period of time, he had this disappearing wind speed. We can use the topography to enhance the wind. We have this acceleration of wind over hilltops, but also we can, on little knolls, we can bump the tower height up by just using the topography. Or at home, we have a 120-foot tower, but it's on a 12-foot knoll. So we bumped up the tower height by just using the topography. Here's the wind profile over various surfaces, best over water. In rural areas, we're going to have about 50% of our energy robbed by just the buildings and crops and what have you. Cityscapes, tremendous amounts of energy are being robbed by the trees, the buildings, and what have you. Lots of turbulence going on in the urban areas. Wind machines, can you have a wind machine in the city? Yeah, you can. Is it going to produce electricity? Yep, sure is, but not as much as on a rural area. Yeah? Can you make a man-made hill and put a tower on it? Yeah, probably. Oh, can you do landscaping to increase the wind speeds up to your tower? I suppose you could.
We have a situation where there had been a landfill, and the landfill's probably maybe 50 feet high, but it's also 30 or 40 acres wide, maybe 50 acres wide, and it's always seemed as though there's considerably more wind on the east side of that landfill than anywhere else. Seems like it's always much better there.
Mm-hmm. Yeah, there's a place just down the road in Wapaka. There's big, huge parking lots and then a hill downwind. And so there's always this updraft of wind coming up off that parking lot because it's being superheated, coming up that hill, cooling down, and coming over that hill. And there was talk of somebody putting up a wind machine over there because at the base of this hill is a Piggly Wiggly or something like that. Yeah.
You mentioned that 120 feet is absolute minimum. If you look on a lot of these manufacturers' websites, it's very common to see towers that are half or even less than half of that. 40, 50-foot towers are just common. Are you saying that something that's half that size, don't even bother, or what?
Well, I think a 40 or 60-foot tower is uncommon. I think that's an uncommon tower height. 100, 120, 140, 160, that's common. Yeah. 120, that's nothing. Yep. That's where the fuel is. If you look at this pink sheet I gave you guys, you folks out in the hinterlands, this is going to be in the first section we did where we did the sizing, this information. On the typical pricing of wind installs, October 2008, when you look at down the typical tower heights, T is equal to tilt-up tower. A G letter is a guide lattice tower, and a F is a freestanding tower, as a matter of reference. These are common tower heights, 120, 126, 105. Yeah, that's common. 40, 60, uncommon. You're going to have a 40-foot tower in Scotland on the coast, where they measure wind not in miles per hour, but in gale force. You're going to have a 60-foot tower in Kansas where there's just sheep, corn. Let's see. We already talked about that. Oh, sighting a tower at least 10 times as far away as the height of the obstacle. You want to get upwind of obstacles. Good sighting. This is at 120 feet at Randy Block's place in Merrill, Wisconsin. He is well above everything in his area. This is my old house, actually. This is at 80 feet, on 80 feet of a 120-foot tower, looking north. I'm looking towards where the prevailing winds come from, and topography drops off after this hill. This is looking across the hill. This valley down in there. This is looking to the east. This is the place where I live now. Tree line, and it drops off right behind this tree line, drops down into a valley. Looking to our south, there's a ridge, a big wooded ridge toward the south, right on the edge of the 500-foot mark. Our prevailing winds, our best winds are from the north and northwest. In the summertime, we get southerly winds, not much energy or very little energy in those southerly winds. Not an issue in our case. We picked out the 3 best spots and sighted the wind machine where we thought would be the best spot, which is actually halfway between the 2 homes. The 2 homes share this machine, and minimize the conductor runs. But we still have this to the south. We don't have the southerly winds, don't have any energy in. And in the summertime, we have the PV to power up the batteries as well. This is the office building where I work. 46 feet is the top of the trees, 100-foot tower. Now, 10 years later, these trees are approaching the 66-foot mark. Red pine plantation. Red pine plantations are meant to be thinned out and eventually regenerated. We're taking out the red pines, thinning them out, and planting mixed forest. So this, non-issue in a few years. This is up in the Door County Peninsula, 80-foot tower, 80-foot tower. Nothing between here and Green Bay on one side, Lake Michigan on the other. Right in the middle of a wind farm. This is Fran Cherney's place. Again, nothing between him and the Mississippi. He's central Wisconsin, so he has half a state between him and the Mississippi. This is poor sighting. This is just up the road from us. Here's a Jacobs. Here's the top of the tree line, well below the tree line. Not much performance there. Here's a wind charger just above the tree line. Not very good. Here's a renewable energy home, PV, passive solar. And then right on the side here is an Air 403 on a piece of water pipe clamped to the house, well below the tree line, just above the roof line. What kind of wind resource is there? Not very good. Putting a wind machine on a building, just not a good match. Here's another wind machine. This guy didn't like to climb, wanted wind. He was off-grid as well, and so not good performance. So an installer came in, talked him into a tilt-up tower, and so his neighbor comes over, helps him tilt down the tower, do the service work, bring it back up again. So now this wind machine works. This is a PV wind hybrid off-grid system, PV array. This is the garage. Down below that is the battery pack. And an installer ran a piece of a water pipe, clamped that to the side of the building, put a 850 Berge up there. So this is the story on this place. PV wind hybrid system. Battery packs would go down quite often during the cloudy weather. Wind just wasn't working real well to power up the batteries. This lady ran the generator a lot. So when you, how does a guitar work? You have this box with a hole in the top. You pluck the string. The hollow box amplifies the sound of that guitar. How is a building built? Kind of a hollow box. You have this thing on top of the roof which has vibrations and harmonics coming off of it. What does the box do for that? Amplifies it. So if it doesn't drive you crazy, the next story will. So the machine is running, creating a frequency and a harmonics built within it. And it's enough to back out screws and bolts out of the building. So what happened was, this is the garage. The installer put the balancer systems, the controllers, inverters on a sheet of plywood, screwed it into the studs, and from the harmonics coming off of the wind machine, backed the screws out of the plywood, and the plywood fell on the floor and smashed some of the components. Installer came, put it back up again, put on new components, and so it wouldn't fall all the way down, put chains on so it would just fall against the chains. So over a period of time, the wind machine created vibrations, backed out the screws again, and the plywood fell against the chains. And then she called an installer, a real installer, and they took this machine, put it out on a properly sited tower, and now she has a PV wind hybrid system that takes care of her needs. Doesn't run the generator anymore. This is featured in a Home Power article. I think this was in Kansas. Here's a nice renewable energy home, solar air, passive solar, wind machine in the background. And this isn't my photo, but I was driving down the road and I saw this place and I was like, oh, yeah. And, yep, go around the other side, and there's a wind machine right there. And now, I don't know when this photo was taken, now these treetops are above the wind machine. Just doesn't work. So tonight you're going to go home. As you go home, you're going to look for trees that are deformed by the wind. When you get home, you're going to get 12 months of electrical bills, add them up, and you're going to look for websites that are going to tell you what your average annual wind speed is for your location. Then tomorrow morning, you're going to get up, jump out of bed, and you're going to start measuring heights of the tallest objects in your area. This might be on your neighbor's land also. You know, if you have your 10 acres, your 20 acres, maybe this will be over at your neighbor's place too, upwind. So you're going to measure the heights of objects. Here we have some ways to do that. Poke a stick in the ground, measure the height. You have a known height, measure the shadow of that known object. In this case, we have an object, a stick 4 feet long, a shadow 2 feet long. Then we have an unknown height for this object here. Measure the shadow. In this case, is 14 feet. What would be the height of this obstacle? About 28 feet. Yep. We're not trying to get within the 16th or 18th, the eighth of an inch. We're trying to get ballpark. What is the height of the tallest object? Within a couple of feet. If you're a Boy Scout, Cub Scout, Girl Scout, Brownie, you have all different methods to measure those heights. I have a friend who's a forester in St. Paul, urban forester, and he taught me this method where you take a stick or a yardstick and you hold it out at arm's length, the tip on your chin, flip it up. Then you're going to close one eye and sight with the other, and you're going to, my object, say, is that wall over there. I'm going to move forward and backwards till the base of the tree, the base of the wall is at my hand, and I'm going to shift my gaze up, and the top of the wall is going to be at the top of the stick. So I'm going to move forward towards the obstacle, backwards from the obstacle, stop when the view of the wall or the tree or the silo or the barn fills the view from my hand to the top of the stick. I stop, mark that spot, and then I measure off the distance. That's the height of the object. All right? That's the lumberjack method. So, here's some other methods here, too. Questions? Yeah.
Much earlier on, when you were talking about the different types of equipment that's available, the smallest one you had was a 400-watt Southwest wind tower.
That's correct.
How high do you put something like that? You surely don't put that on top of 120.
The question is, would you, the smallest machine in some of the information earlier was a 400-watt air. You wouldn't put that on a tall tower. Nah, you wouldn't even mess with that. But the next step up, like the Whisper and the Berge 1000, yeah, you'd put that on like an 80-foot tower, and you would do the general sighting issues also, 30 feet above everything within 500 feet.
So that little one, is that one that you put on the top of the building just to charge up, a battery?
No, that's the one that you would put on a sailboat and charge up your sailboat batteries. That's what it was meant for. Yep. There's a home in Manawa, Wisconsin. I've not been there, but I've seen photos of it. Has 6 of these mounted up on the roof of their pole shed, charging up, I assume, batteries. There was a Y2K installation. Probably never produced a kilowatt hour in their lifetime. Probably never did. And again, produces as much energy in the box as out of the box, in a sense. But you would, and that's what makes small wind on the small side, from the 2500 kilowatt on down, for 2500 watt on down, so expensive because you have this small output on still needs a tall tower, concrete, conductors, and all that jazz, but it's putting out so few kilowatt hours per year. That makes it an extremely expensive dollars per watt to install. Versus a machine like a 10 or a 20 kilowatt machine or a 30 or 90 has, they need a tower, they need concrete too, but on a lesser scale overall. And so the dollars per watt to install a large machine is far less than a small machine. So it just doesn't make sense to put a 400 watt machine on a 120 foot guide lattice tower. Just doesn't make sense.
That's basically designed, like, say, for a boat.
Yep, designed for a boat. And that's what it does a very nice job doing that. Yep. Anything else? Other questions? What about you guys in the hinterlands?
This is Bartholomew County.
Uh-huh. Yep. I can't hear you.
What is the cost per kilowatt hour considered reasonable for a wind generator?
You mean dollars per watt to install?
Yes.
Okay. So, and I'm just talking in generalities, okay? In generalities, let's compare it to PV. PV is pretty consistent from small to big. And dollars per watt to install in general. Utility intertie PV system, no batteries, is about $8 to $10 a watt to install it. Okay? That includes parts, labor, everything. You just write the check. On the small side of wind, you might be looking at as high as $16, $18 a watt to install a small wind system versus a large wind system, which might be about $4, $4, $5, $3 a watt to install. Any idea what it costs, say, like a Windspire or a? And what's the output of that?
Rubber hits the road.
That's right.
What was that?
1.2K.
So here's a 1.2 kilowatt Windspire, about $15 a watt to install it. Extremely expensive, and that's the nature of this beast. That's like I was talking about this gentleman, this wind machine, this 400 watt machine, extremely expensive to put up on a tall tower because it needs a tall tower, concrete, conductors, and all that jazz. Same thing as a larger machine. Did that answer your question? Oh, endurance. What kind of dollars per watt are you looking at? Do you know?
Oh, jeez, I'd have to do the math. But our system, all included, turnkey operation, 105-foot tower, is with the service package is $50,000. So I don't know what that works out to be. It all depends. You're going to get about probably an average of 10 to 12,000 kilowatt hours, depending on your wind speed. So
you're looking at maybe about $10 a watt to install, ish. So once you start getting up in like that's a $10 a watt to install. Simple utility intertie PV, $8 to $10 a watt to install. Well, once you start getting into the larger sizes, the 10s and the 20s, then you're starting to drop down the cost per watt.
Clay, the other thing to mention too is that there are incentives out there, like you mentioned before on the Desire website. So right now for a resident, you can get 30% as a tax credit back. It's not actually a check paid to you; it's a tax credit, but it is real money. So and you can defer that forward each month. So there are incentives out there. So on a $50,000 machine, that's $15,000 credit. You're down to $35,000. So now your cost just went way down from $10 to.
And the state of Indiana has a grant program.
USDA. The USDA has the REAP program.
Yep, they have that's cash in hand, right? USDA has a grant program. The state of Indiana has a grant program also, which is going to be renewed July 1st. Oh, really? Chris?
I thought there was one for.
The grant program we're referring to is the APE, Alternative Power and Energy Grant. It's a competitive grant program which is renewed every fiscal year, and July 1 is when it'll be announced.
Yep. And that's cash in hand.
Was there?
Yep.
The APE grant is for businesses, not-for-profits, schools.
Oh, Chris, is your mic working?
Yeah, I can get it.
Okay, you meant to push the button again.
There you go. The AP grant is for businesses, not-for-profits, and schools. And that is up to $25,000.
Yep, my bad.
Was there any discussion about the USDA REAP grant program?
No, do you know much about that?
Yeah, that's a federal grant program that we've been doing a lot of outreach here in Indiana to attract more applications. And it's Rural Energy for America. And you have to be a rural entity, business entity, not a rural residence, but rural. So you're a farm or a IGA store in a Florida, Indiana, like where I'm from, or some of these other small areas, rural areas, you can apply for up to 25% grant funds to install a renewable energy system, wind turbine unit, anaerobic digester, solar, geothermal updates for energy efficiency projects. We've been doing a lot of energy audits for grain drying systems for farms. So if you're interested in that program's part of the Farm Bill. It's mandatorily funded. If you're interested, go to our Purdue website. We've got a link to the information about that.
Yep, great program.
And there's a low interest loan program as well for 50% of a project.
Yeah.
So if you're
if somebody were to utilize all these grants and tax credits and put them all together, conceivably, what could a normal homeowner, residential type of an application, what percentage could you get off of, say, like a $50,000 install? I mean, if you did your due diligence and got it all, approximately.
I don't know, about 55% could be averted through grants and incentives and federal money. Yeah.
All these others were businesses, right?
Okay. If you had the USDA grant, DA grant, the Indiana grant, and then you have the Fed tax incentive. Yes. The USDA is business-based, and Indiana was nonprofit or government or something like that based.
Chris, it's businesses and schools, nonprofits.
Yeah.
Okay.
Business, school, nonprofit.
Just residential is really a challenge other than tax credits in Indiana.
Yep. And so in your state, residential would apply only to the federal tax incentive, which is 30% no cap.
Rural electric, or not rural electric, rural energy isn't, you can't actually use that for your home, can you, in that? I thought there was some kind of stipulation. It was just strict.
It is not. Sorry for the technical difficulties here. Yes, it is not for residential. There's a pretty strong message that came from USDA that residential is not applicable for the USDA funds. It has to be used for a business entity, farm, small business, or whatever it may be. So.
Can't even use it for the residents on the farm.
No. Yeah, you would not be able to, because they will come by and verify and see if you have an extension.
Chad, one thing though we found out is you can actually install a second meter. Like if you only have 1 meter on your property, but you want to use it for the farm use, but you only use 1 meter on the whole property, you can actually install a second meter, and then they'll.
Yeah, I think we need more. Our power's running out of our microphones. But yes, if you did have a meter that was associated with a business entity. But more details on that, you can go to our website. We'll move ahead beyond the grants here.
Yeah, there's more reasons beyond simple payback for putting in a renewable energy system. There's 100 and some people here, 200 and some people off-site. You have some sort of buy-in or idea that this might be cool. You're here for other reasons beyond economics. One more question.
Yeah. What were you saying the dollar per watt for a larger wind system you could expect?
It goes down as you go larger in size. You could be down to the $4 or $5 per watt to install on the large side.
Solar, I understand that solar cells are going to be coming down considerably in price because silicon's much more available now than it was, and one of their main raw materials.
We'll see. Right now, they can make them solar panels for, was it $3 a watt? And they're hoping to get that price down to $1 a watt. And when it goes down to $1 a watt, we're going to be installing a bazillion of them. Yep, a lot of them. So if we can, but that scale of efficiency, production side has to be tooled up also. We don't have enough production on right now. And the Germans and Japanese are buying up everything that can be made still. Sizing, how are you guys doing on sizing concepts? So you're going to define the load, 12 months of the year. You need to know what the wind speed is for your site. And then you're going to use that chart that's in the book. Use that chart. You got a production side and a resource side. You're going to match up a machine that's going to meet your consumption. Yeah.
Would it not be just as reasonable to go, okay, I'm not getting anything May to early August, why don't I just ignore that part and look only at what I need the other time to size the wind, and then do photovoltaic for the summer stuff?
Oh, yeah. Yeah, we didn't, I kind of glossed over that, didn't I? So you can take and make a system, a PV wind hybrid system, where we're going to meet, this is how you do it. You define the annual load, and you size the PV array to handle 1/3 of that, 3 months. And so you're going to downsize the PV array, and so that'll meet your needs in the summer. And then you can downsize the wind machine side and size that for 2/3 of your annual load. So you're going to decrease that size also. So you're going to have a machine that's going to meet your needs during the fall, winter, and spring, and then a PV array that's going to make up for that other balance of that production. So 1/3 wind, or 1/3 solar, 2/3 wind.
It seems like you could be a lot more specific. I'm on LP gas,
Mhm.
and so my electric in the winter is way low. It's my cooling costs in the summer
Mhm.
that really drive my electrical consumption. So
Mhm.
I would think I would even be lower for the wind needs.
Unless net metering plays it. Unless net metering plays a fact. Because if you could,
Right.
if you could stay under 10 kilowatts and still have enough to produce for your whole house, then you basically can roll it. Depending on your utility, sometimes you can either roll over those credits to the next month, or you can actually get a wholesale cost for anything additional that you make and use those as credits
Mhm.
towards the months that you don't. So that's why net metering is the big player in this. So if you can, push your utilities for net metering, that's a great
Yep.
thing.
And your Public Service Commission, because there's the people that make up the rules. Yep. For the utilities. Does that kind of answer your question? Okay. Are we cool on sizing? Got some exercises here for you. Next up, in the next 15 minutes, we'll just fly through the good, bad, and the ugly. This is just things I heard on the street. This is only my opinion, all right? AWP, made in South Africa, now available in the United States again. The ARE 110, this version on steroids, tweaked up to 2.5 kilowatts, very nice machine. Now, they used to match this machine with a 2,500 watt Windy Boy, but once the machine got up in those high winds, got up to 2,500 watts, anything above that, the inverter would drop out because it was out of specs. So now they're mating it with a 3,000 watt Windy Boy, so now it can go up into those higher levels, bump up above 2,500 watts, and the inverter won't drop out. So in the really good winds, the inverter hangs in there, a nice match with this machine, and a little bit larger inverter, better performance. Same with the Proven. Proven 2,500 watts. You get up above that 2,500 watt rating for any amount of time, the inverter will drop out and wait 5 minutes to resync. So you're losing wind, you're losing power. So now they're mating that with a 3,000 watt inverter as well. The ARE 442, 10 kilowatt machine, just a screaming performances. Oversized rotor, just a great machine, but it has that noise associated with those harmonics coming off the machine. Really kind of is a loud machine. And if they can't lick that problem, they may not be in business. Just a screaming machine though. So if they have issues, they need to solve that problem. Lots of these machines out there. Lots meaning in the low hundreds. Skystream, 1,800. New versions coming out are what size? A 3 kilowatt machine?
Yeah, they're trying. It's still in testing right now.
Oh, okay. Some issues with the software and programming of it.
A lot of issues.
So I think they're underselling this machine. I would like to see this machine on a taller tower, and I think they could get some really cool performances out of it.
Yeah, you can buy this machine at Home Depot and Harbor Freight now.
Cool. You used to be able to go to Target, the online Target website, and get a 1 kilowatt Bergie and a 80-foot tower. I don't know if you can do that anymore. Used to be able to do that when that Bergie came out. Here's the Swift coming out of Scotland. Hugh Piggott rips this whole concept apart on his website. They're selling it as a roof-mounted machine. The fuel just isn't there. It does great on a properly sized tower. But this manufacturer is selling you a machine, not the technology. Yeah, yeah, because what do you got here? You got a little bit of turbulence going on here. Yep, absolutely. Yep. Any machine that's going to hunt around for the wind is in turbulence. State of California spent millions of dollars with this machine trying to make a better mousetrap. Carbon fiber rod, end to end. There's 1, 2, 3, 4, 6, 7 rotors on this machine using this blade here. This blade. So I wrote this guy. I was like, hey, I'm teaching this class, 6,000 watt output. I'm interested in that 6,000 watt machine. Here's where the generator is. How much is it going to cost? And he's like, yeah, we can build one, not a problem. And I wrote him back. It's like, no, I don't want one. What would it cost? He's like, yep, send the check and we can get started anytime. I'm like, no. How much would that machine cost? Because I was trying to get can this compete with other machines, And he's like, yep, absolutely. We are very interested in building a machine for you. So he never had a price tag for it. But, trying to build a better mousetrap, how long is this carbon fiber rod going to last? And can it compete with other 6,000 watt machines? And maintenance issues. Here's another version of a 1,000 watt machine. Just trying to build a better mousetrap. And good stuff comes out of this, eventually. Here's an internet machine, the Mallard. These are the blades off of the 403. They have 6 of them. Delco Remy 12-volt alternator off the shelf components. And then some sort of adapter to a water pipe and a sheet metal tail. $500, 800 watt output at 40 miles an hour. So I was teaching this class in Mason City, Iowa, and there was a construction worker who came to the class. He sat in front over on the right-hand side, and he's like, yeah, I got this wind machine that I bought. Put it up in the back pasture, and I'm charging up batteries, and I want to run the fencer, but it's just not working out real well. We got to this slide, and George is like, hey, that's my machine. And so he put it up per the specs of the manufacturer, 20-foot length of water pipe, just wasn't doing the job. The solution, run down to Fleet Farm and Fleet, get yourself a solar-powered battery fencer. And just not going to do the job. So buyer beware. This is a pack wind. This is I saw the only episode of Living with Ed Begley Jr. on some home improvement show. The only episode I saw was the one where they put a machine up on his house. They bolted it to the side of the building. Not this machine, but a different one. Here's the alternator right here. So after that episode aired, we had lots of emails from people that's like, yep, we saw that episode, we want that at our home. One was a teacher who emailed and is like, hey, we're building a 4,000 square foot home, we're breaking ground in 2 weeks, we're too far away from the grid to really it's going to be really expensive to bring in the grid. We want one of these to power up our home. It's like, well, so, people see this, it's not reality, it's not grounded in reality. People see this and they want it. And again, another poster child for what doesn't work, Wind, of course wind doesn't work. So I sent her a lot of information, and she wrote back, she's like, well, that's not what I wanted to hear. I really slagged off Ed Begley Jr. until a couple months ago. There was a building conference in Wisconsin, and we had a booth right next to him, and a workmate of mine was talking to him, heard him talking, and he actually took his pack wind down, didn't do what it was supposed to be doing, but consumers didn't hear that side of the story, This is the kettle chip factory in Beloit, Wisconsin. You go up 39, just right across the border, and you stop at that wayside. If you're ever up that way, stop at that wayside, go to the east side of the parking lot, and then look to your east. That's this. That's this building right here. And there's 18 of these 6 kilowatt machines on the parapet of the building, and every time I pass through there, I'll stop at that wayside and look at the machines. A couple will be spinning, nothing else down here, or maybe one or two of these guys will be spinning, nothing down here. It's just totally at random. And this is a smart group of people. These are defense contractors. These are the folks that bring you the drone that whacks wedding parties. They put scoops on these machines here, blah, blah, blah. I was going to take this slide out because I hadn't heard much about it. It was in development. But then an installer came through and he's like, hey, I saw this new thing out there. It's based on a helium balloon. And I was like, wait a minute. So I dug up this photo, and so they're hawking this machine again. It's all a concept yet. Pay out a bunch of cable, get it up high. Sounds reasonable. Some sort of helium or hydrogen balloon, axle through it, and then a generator on each end, and then transport the power down the cable. Still just a concept, but so I just kept it in. The Turby coming out of the Netherlands, vertical access wind machine, true airfoil. Where's the greatest stresses on this airfoil? Right in the center. Where's the most amount of work being done? Right in the center. So I have to beef up this center section right in here. I don't know what kind of performances are coming out of that. Madison Gas and Electric is monitoring a wind machine, a vertical axis wind machine. Go to mgne.com. Madison Gas and Electric. And they have data coming off of that. It's been up only 2 months now. So look, they're going to do a month's test, a year-long test on it. Here's another internet machine. I was going to take this out. I was in a class just recently, and one of the students had the spec sheet, the cut sheet off of this machine. And he's like, hey, what do you think about this machine? It's a 5 kilowatt machine, internet special, metal blades. And we got to this photo here, and it's like, well, there's a machine right there. Whether it could really perform at 5 kilowatts, who knows. But that's not a 5 kilowatt rotor on there. A 5 kilowatt rotor, how big is the endurance? 18-foot rotor. That's not an 18-foot rotor. So collector's everything. If this doesn't have the rotor behind it, it's not a 5 kilowatt machine. More like maybe a 1,000 watt machine or less. Darius rotors, we may see these come back. Nice performing machines, but they were low to ground, right on the ground. Lots of issues. Two-bladed machines, also called an egg beater, but extreme forces on the center of these blades, they would just couldn't hold them together. We may see these comes back in another evolution or a new form. Guide off. I think we'll see this come back. The wind tree. This was out up until about 5 years ago, and then it got a lawsuit brought against them. It's a multi-level marketing scheme. You buy into this product, and you're going to get one in 6 months, another 6 months, and another 6 months, and another 6 months. Multi-level marketing scheme. Never saw an actual machine. You always saw an artist's rendition of it. I think we'll see this again as energy prices go up. Here's a larger version of that in a different publication. There was, not in my class, but somebody else's class, these people had took all their retirement money, invested in this company, and then they learned about the product. It didn't really exist. This is in a renewable energy trade magazine. A cowling or some sort of shroud over the blades to funnel down and compress the wind as it comes through the blades, get better performance. Wind is lazy; it just goes around them. Lots of work has been done on this. Lots of steel, lots of materials involved with this. And then my last one, again, another one I was going to take this slide out, and there was a student that's like, there's this new thing out there. It looks like a jet engine, and it compresses the wind as it goes through the blades. It's like, wait a minute. Dug up this slide and is like, is this it? And he's like, yeah, that's it. Storm blade turbine, limited, bloody, bloody, blah, ultra efficient wind machine. Accelerating the wind onto the blade. Storm blade is efficient in low as well as high wind. Can convert up to 70% of the wind power into electricity, double the current average. What do we know about Bett's law? We can only convert about 54, 59% of the energy into usable electricity. So that even the laws of physics apply to storm blade turbine. So they got something going on in London that we don't have here. Questions? That's what I got for you. What kind of questions you got? Let's go to the Outlanders again.
We have a question in Tipton.
Yeah.
Have you heard of a wind spire vertical?
Yeah. Actually, we have some of the pieces here. I don't know much about it. 1.8 kilowatt output. Actually, I'm looking at the generator right now. Is this a generator?
That's the inverter.
Oh, this is the inverter. Oh, yeah. This is a Mariah. I'm sorry. This is a Mariah wind that I'm looking at. Really? For real? That's the same? Oh, really?
They just changed the branding issue. It's all Windspire now. But it's
Okay.
made by Mariah Power.
Got it. Check. Go to the website. Check it out. What else we got for questions?
Concerns over birds and with wind turbines.
Oh, yes, birds and wind. There's been lots of studies done in relation to that, and it depends on who does the study. But in general, on residential scale wind, not an issue. Utility scale wind, okay, let's back up to residential scale. Residential scale, not an issue. Small rotor diameters. I live with 3 at work, 1 in the backyard at home. I've seen no bird deaths from those wind machines. I've heard of a owl colliding with a whisper. Neither fared well. So can wind machines kill birds? Absolutely. But we aren't looking at like giant bird Cuisinarts in the sky. What we're looking at is on utility scales side about 1 bird per turbine per year. So do wind turbines kill birds? Absolutely. But let's look at the big picture. What else kills birds? We have tall towers, we have windows, we have guy lines, and the cat.
Cars, trucks.
Cars, trucks, pesticides. The average household cat kills 300 songbirds a year. So let's outlaw cats, you know? So, yeah, let's look at the big picture. Let's be real about this. Come on. That's lots of reports out there. What else?
What do you think is going to happen to the cost of energy when the United States gets more and more dependent on these wind energy turbines, and then come along June and July where there's no wind, and these power companies that have to generate a lot of power in that time frame but have to shut down and buy back the electricity during the winter months?
Mm-hmm. I think we're going to need a combination of everything. We're going to have to take care of the base loads with coal energy, and we can supplement and have some of our energy coming from wind and solar electric as well, and biogas and all this. It's going to take everything we can generate electricity with in a smart way. That's going to be our whole mix of energy. It's not going to be just one thing. It's not just going to be one answer. And the utility companies in Wisconsin, they're encouraging, we have the wind side, but they're also encouraging their homeowners to put in solar electric also on their homes. And they're going to pay you a premium for that production. And that's the time we have the most, the peak demands in the summertime is when solar electric shines. The wind doesn't shine as much. And so you put in a renewable energy system, you own it, you maintain it, the power company is going to buy all your electricity off that system at 25 cents a kilowatt hour for 10 years. You have a 10-year contract. So I don't see wind being the answer. I don't see solar being the answer. I see all of these energies being an answer to the problem. Yep, absolutely. Again, think about Germany. Here's a nation who's buying into wind, buying into solar energy, base loads being taken care of coal, and they're a net energy exporter on sunny, windy days. Yep, absolutely. It's going to take everything. Yeah.
Hendricks County with a question?
Yes, go ahead,
Where
Henry.
could a person get a list of reputable people who would do site assessment and make general recommendations?
Good question. Chad?
As far as a listing of reputable people, I mean, you can go, but a list of people, at least at minimum, is the American Wind Energy Association has a link for residential wind installers. I would do some homework, talk to some folks who maybe ask them for references. But as far as like a consumer's reports on some of these different installers, I'm not aware of anything of that.
Yeah, we don't even have that. We just have a list of installers and shop around, get references, go and see their work, talk to their customers.
That's the best way. I mean, Purdue at university is not going to endorse anyone over another. I mean, that's just not our role. But I think there's some due diligence in store for folks that are looking to do this and look at AWEA's website to find that list of people.
We have a list of MREA trains and certified site assessors, and you have currently one person in the whole state that will do solar water or solar electric. No wind site assessors, to my knowledge.
I hate to continue to pitch the renewable energy website at Purdue, but we've tried to make this a hub of information. But you can go to our website on the wind page and find that link to the AWEA list of residential installers.
Good. Yeah.
Clay, something else too. If there was anyone up there that you guys thought you might want to find out more information of, all of the, pretty much probably 90% of the ones that he mentioned have a website out there. So if you just go to one of those websites for the actual manufacturer and then ask them for a dealer in your area, they'll usually, the dealer will either be on the web page or they'll be able to pass it on to the dealer in your area.
But shop around, get references. Yeah.
What is the solution, how to say this? What's the best we can achieve with wind, given our current energy needs? What percentage is wind a solution?
Oh, gosh, I don't know. Part of the problem is, right now, is where the good wind is, there's no transmission lines or poor transmission lines. So we have to build the infrastructure to get there. North Dakota, Montana, Wyoming, South Dakota, Iowa, that whole corridor area has oodles and oodles of wind energy, but we don't have any transmission lines out there. So we have to invest in this infrastructure. I don't know the answer. I think there's certainly enough wind energy in the United States, enough solar energy in the United States to take care of all of our needs, but it's not there all the time. We have to take care of the base loads with some other source, like coal or what have you, and make up the rest with renewables or what have you. It doesn't answer your question, but I can't pull the figures out of my head. It's 4 o'clock, 5 o'clock.
Where I want to site mine is probably about 1,000 feet away from my house. Is that a bad idea just from the length? Because that is where the wind is best.
No, what you're going to do is you're going to find 3 sites around your place, 3 best sites, and then start eliminating. This is too far. This is too close to a tree line, blah, blah, blah. But if the one that's 1,000 feet away, yeah, you're going to size the conductor for a minimum of 2 to 5% wire loss. And it's just a matter of bumping up the conductor size. Yep. Anything else?
Yeah.
Yeah.
How does one become a site appraiser?
You can work with an installer and learn the trade on the job. We offer training. It would be a 4-day training class and practice assessments that you do. You do a practice site assessment in the class. And then there's testing involved. So it's maybe as soon as a 6-month process to get through that and do that. Yeah. Currently, we're the only ones that train people, but there's all sorts of installers that can do site assessments as well for wind. Does that answer your question? Well,
We have a question on the Grand
how do you
Canyon.
become a site assessor? On-the-job training, number 1. Number 2, go to a place that trains and certifies people. That's what we do. Yep. the-mrea.org. We're the only show in town right now. But, you can take but you can hook up with an installer and learn the trade too. Yeah?
What was your company name and contact info and your company name and contact info?
They have stuff down here. There's something that you said. Essentially, what we did today is what a site assessor does. They go to a home, they look at the loads, they look at the wind resources, they match a machine with the loads, they go through, make energy efficiency recommendations, they measure out the tallest objects, they get a minimum tower height, and they look around the property. Where's the 3 best places we can put this machine up? Identify those areas, and they recommend a tower type. That's what a wind site assessor does. You just had a 4-day class jammed into 6 hours. So the tools I gave you is what a wind site assessor uses every day. This piece of paper, this is the charts that they operate off of. So you have a start. Okay, let's go to the outlying areas, the Auslanders. Anyone else?
LaGrange County, we have a question.
Sure.
On your utility grade inverters, there's with the phase matching, do you have a particular brand that you actually prefer over the others? Because they all say they are the most efficient.
There's not much out there. The Bergies are going to use a Xantrax inverter that's made for them. The Jacobs, the Wind Turbine Industries machine, is going to have an inverter made for it. You can't use that on anything else. The only 2 other inverters we have out there is the SMA Windy Boy, which is really nice, and you can stack them up too. You can take a bunch of 3 kilowatt inverters and stack them up, so one cascades to the next, the next, the next. And then the other one out there is the Magnatech made by Power One. The advantage of the Power One is that you can go in and change the parameters and match it up with virtually any machine. And I talked to somebody about gasification and running a generator off of that. And you might be able to take that one and use it in that application. I don't know. So there's 4 inverters out there. 2 of them are made for the particular machines. Then you got a Power One and a SMA. Here's the Windspire one that has an inverter made for it.
If I could add to that, Xantrax is a very large power supply company, and they make a lot of inverters for different applications.
Yep.
And they're very, very reliable and very knowledgeable.
And bankrupt. I think they got sold out. I don't think they're around anymore, or will be around very more.
We just have about 3 minutes left, and then we're going to be out of time. But maybe one more question.
Sure.
Yeah.
How about the Auslanders? What else? Anything else? Anyone in house? Yeah.
Yeah. What was the name of that book you were talking about by Dan Shiras?
The book by Dan Shiras. That was supposed to be out in March, and it's not out yet. It's Residential Scale Wind. I don't know the title of the book, but go to danshiras.com and you can get it. He also has a company called a training institute, which he just opened this winter, evergreeninstitute.org. He actually does training too of wind site assessors, and he's one of our assessors. Yeah, he teaches for us once in a while. Very smart guy, and he writes his books so that me and you can understand it. Yeah.
You talk about the 6-month maintenance, and that's going to add to the overall cost of the power. How much do you charge for that 6-month maintenance? Is it like a $500 checkout?
No clue. It's you can have a service contract. You can hire a crew to come out and do it, all over the board. Assume that you're going to spend about 1% of the cost, 1% each year on the maintenance and service of that machine. About. And you're not going to spend all that 1% up front. Year 2, 3, 4, 5, but maybe year 6, maybe you got something major to do. I don't know what that could be. So you're going to save up for a while and then spend money. Then you're going to save up for a while and then spend money. So overall maintenance cost of that system over the life of the system is about 1% per year. And we need service people out there. Everybody wants to be an installer, but nobody wants to do the maintenance. So we got all these wind machines out there that need service, and they need work on them. And it's clean jobs too. There's electronic parts that need to be refitted, and there's only so many service centers in the United States, and they're busy. So there's room for electronic people, there's room for mechanics, there's room for all sorts of people doing the service side. You know, it doesn't make sense to have to wait 6 months or 3 months. We know people, we've had to wait 3 months for a service guy to come out, and we have connections, and we can guilt people into it. And it still takes 3 months to get a wind mechanic out. And it's difficult for a service place to load up the truck, drive 800 miles to do a $20 job. It has to be local. Okay, that's about it. Thanks everyone for coming. Great class. Thank you.
Let's thank Clay for a good job.